Hey guys, welcome back to the channel. I have another interesting video. This time, board. The computer is already out of the case, so the board is out of the case of the computer. This is a 2020 Ford Motorhome with a 6.8 liter V10 engine. Customer concern is injector 8 and alternator light on all the time. So I have the fault codes and everything to show you, and the information that I want, or that I have done or gather for you. So I'm going to show you my findings in the board. I have requests like, can you please show us, more of what you do in the boards and everything. I'm like, okay, well, let's do it that way. See if this is what you want. All right, so that is the board. I'm going to show you. I will show you pictures so you can get to see everything. That part in there, you will see or understand pretty soon why I have it scratched up in there, because I was doing some tests. But let me take you over to the folder as I normally do for each customer. All right, perfect. So that is the information. So let's go in order. As I normally do, I take a picture of the board of the computer before I touch it to make sure I got all the part numbers and everything. So the customer name is David Rowland, and his son is Brandon Rowland. They're both from Florida. Brandon works in a shop, and they're the ones that are working in the car. So again, as you can see here, injector 8 continuous fire. So that means it's continuously ground. And the alternator fault light on. All right, so that is the information that I have from him. And in here, we're going to read Brandon Rowland, Price Automotive in Florida. The computer for a 2020 F53 motorhome with a V10 Ford engine, information included, and that's all we need from there. These are the full codes. So he has P0208, cylinder 8, injector 8, circuit open. P0308, cylinder 8, misfire detected. P0316, misfire detected on the startup first 1000 revolutions. So it's a continuous misfire. And it has also the P0620 and the P065B. Those are for the generator control circuit, generator A control circuit range performance. So I'm like, it's kind of weird. What kind of connections is between these two? Because, going into the wire diagrams, which I have all, this computer is a Continental. I'm not sure about the part number because it's or family, because it's nothing in there reading. This computer has two connectors, one with 103 pins, which is connector C175B, and then the other connector with 95 pins is connector C175E. I can put the connectors in there so we can have it. Actually, let me close all this that I have opening here, and let's do it in order. So I'm going to open the connectors. So that's the connector, the way the connector B looks. I'm just going to make it a little bigger so you guys can see the pinouts. The computer has the pins marked internally, so that's very nice from Continental to do that, because it makes it very easy for you to follow the pinouts, right? So you don't have to guess where, what is what. I also gather the flow chart for those two codes. You can see here, charging system 6.2 liters V8 and 6.8 liters 3-ton 30 valve V10. That's what it really fits on there, and it also fits those vehicles, the F250, 350, 250, 550 Super Duty. If we go down, we can see the codes in here, as we have the description before, P0620, 620 generator control, and 065B generator control circuit range performance. So that tells me to go into test E. I'm going to scroll quickly down because there's multiple other tests in here until I see the E. So sorry if that gets you dizzy a little bit, but I want to try to make this as quick as possible. We're still in B. So let me go faster. I'm not sure. That's the one before those two. We are already in the test for the 620 and the 625B right here. Now let me get a box. Hopefully I can, yes. This is just to use it as a mouse. So pinpoint this E for those two fold coils because they're pretty much a match. And it tells you, if we scroll down, believe me, I already went through the whole thing. It's not really much that they tell you to do here. I mean, it is a valid test. They tell you to disconnect the battery and connect and check connections. And use a test light, which is actually the first time I see Ford recommended to use a test light to check the actual alternator. Let me just keep going down until I see the pins that I want, which is right here. All right, so let me get a box in here. I want you to read right here, C175B pin 13. That's very important because that's the pin that I'm going to use for the test. I'm going also to get the injectors diagram. All right, so that's injector diagram, and I'm going to zoom in a little bit so you guys can see better. Let me get one of those boxes as well. Injector 8 is right here, and it's connected into pin 62 in the connector C175E. So C175E, pin 62. So it's in completely different connectors. The alternator pin that we're going to test is in C175B, pin 13, and this one is, the injector is in C175E, pin 62. I also am going to show you with the diagram for the alternator. Again, this is all original Ford information that we indeed, let me get that box as a mouse again one more time. So we got it right here. So generator RC and connector C175B, pin 13. That's the one that I'm going to do the test with you in the computer. And you're going to see why I have the computer out, because you're going to say, well, Mike, you already got the computer out. Oh, yes, I do. Well, let me move you here. And now we get that very close. I'm going to put the meter, because we're going to be using the meter for the test, the one you can see on the screen right now. Let me move it over to a place that is not in the way. And make it a little bigger. So this corner is not really that much of an interest for nothing, right? So I'm just going to make it a little bigger so you can see what I will be doing a test with. And we're going to use it just in continuity. Continuity in resistance. So let me move it to continuity. Oh, I have to do it in the software. Forgot that I already have that on, so I have to change it on the software. And it's continuity right here. Okay, right now we have it in continuity. As normal, always you should, if you're doing any tests, you want to make sure that you check your equipment before you perform any test. So I'm going to short the two leads together to see what we have. And we can see that we have continuity 0.01. So those are very good leads. All right, so the first thing that I'm going to do is connect it into connector C175E, pin 62, which is right here at the bottom. Now that I know that my equipment is good, I'm also going to find a pin, and I already know what it is. It's right here. So we can see that 0.01, 0.02, so it's perfectly right there. So following along on the board, that's for injector number 8. So injector number 8 driver is right here. And we can see that that is indeed the driver 0.02, 0.03. So it's just a little bit of a resistance. I mean, nothing, right? So that is definitely the driver. So this is the driver for the injector. You will be like, okay, well, Mike, that's it, right? That's what you need to replace. Not yet. What I want you to see is this. So I am in here. And you are seeing that that's pin 62 on connector C175E. This is C175B. Pin 13 is right here. But look at that. 3.8 volts. 3.8 ohms. The alternator signal, which is to control the alternator, is shorter to injector number 8. And the problem is, and that's why the injector is it's acting up like it's going on all the time because this is a pulse width modulated signal. So the computer is pulsing that injector in very short times, on and off and on and off. So it's pretty much staying on all the time. These two circuits are completely separate. And I also follow, and this is what I want to show you because the alternator control circuit is here. And it's on this pin. Let me just, I don't have my glasses on. Let me put my glasses and get a little closer without being in your way. But I can tell you it's right there. Look at that resistance, 3.78. You should tell me, oh, you will say, well, Mike, that's the other resistance is 0.3. That's 3.8. So they're not together. Oh, yes, they are. Any circuitry inside the computer, and I'm going to prove you this in the same injector driver, they have thousands of ohms of resistance in between. You have never, nothing in between 3 ohms. 3 ohms is what this is telling me is these two signals, either the injector got shorted or the alternator got shorted and shorted out the board internally. So those lines, probably in the layers of the board, got melted together. Not completely, because otherwise we'll have a zero, but they're so close to each other right now that we have 3 ohms of resistance, which is nothing. That will actuate either the injector. When the injector is being commanded, it's sending the signal to the alternator, and vice versa. When the alternator is being commanded, it's sending that signal to the injector all the time. And this is the problem with this computer. And what I wanted to show you is I'm going to, again, this is the, let me just make sure. Yeah. This is the injector driver. This is the, so these are, let me just get the data sheet, which I have here for myself, because I don't want to share that with all of them, because this is for internal information only. These are double MOSFETs, so I want to see pin 1, 7, and 8. Let me just 1 second. So I have, give me 1 second, guys. Where is the other one right here? Just to make sure that I give you correctly everything. So we have gate, heater is down, and the collector is on the top. All right, so what we have is, this is the sorry about that. This will be in this MOSFET, or this one, sorry. We will have, this will be the collector, which is in this case controlling the injector. We will have a base, or sorry, a gate in here, and then the emitter, which is most likely going to be connected to ground on these drivers. And I can show that too, if I am correct. And the pins are correct, because this is like two MOSFETs into one. So I know the pins for grounds are here. Let me just make sure I'm saying that right. Yeah, I think these are these 3. Yeah, these 3 are grounds. So one of these 2 for that specific driver should be ground. Right there. You see right there? So we have definitely a ground in here. You see it's 0.01. So that is definitely an N-channel MOSFET. And then the other one is the gate or base, you know. So that is correct. So give me 1 second, guys. All right, where were we? It was a customer picking up a computer. So, oh yeah, so we were on the ground test, and now you know that we are in the correct assumption. So everything is as I said. And the reason I'm showing you that is because the resistance check, right? So let me just get one image for myself in here so I don't forget which I'm checking. Yeah, the bottom one. Again, I'm just not going to show this because it's my personal information. But so what I want you to see is this. Like in the same circuit, I'm going to use the light to see. Okay, so we are here. This is the component that is shorted. I'm going to touch the pin 13 one more time, which I have marked. Come on. You got the same 3.7 ohms, right? So right there. So this, you will say, okay, well, it's 3.7 ohms. So this same component to ground, look at the resistance measure. It's open because I'm in continuity. So, but it's such a high resistance, it shows as open. And I'm going to move it over to the gate. And it's still open. Hopefully you guys are seeing that. Yes, you can see it. I'm going to change the readings now to resistance. So this is a very accurate tool. Let me just get that 1 second. 2-wire resistor. Okay, now we're in resistance. Okay. And we're going to do the same test to see what changes or not. We were here. I'm going to touch into pin 13. So yeah, that is very accurate, 3.74546. So that is the resistance that we were reading. If I go over to pin 62, which is the one for the injector, we got 0.187. So we can see that it is a small difference in resistance, but not major. But if I measure the same component here, the same method, from ground to the emitter to collector, come on. This overload is like over 100 million ohms. And then from that to the base, overload. So you can see what the resistance is. It is such a high resistance. And I have a resistor right here that goes over to the signal, to confirmation. So you can see that's a 2.2 kilo ohm. So you see this is the same path that we have in here. So if I touch this side to, so we can see that this is, I'm just going to touch in here. We got the same place, but on the other side of that resistance, we got 2.2 kilo ohms. And that's what you usually see. So you are always in boards, you're going to see, 2.2 kilo ohms, 260 ohms, 360 ohms. 3 ohms is a dead short. 2 ohms is a dead short. You can see maybe, if you're measuring a solenoid, 16 ohms, because it's a load, but not inside the board. So yes, when you see something like this, the only thing that I can think of is in between the layers. And the reason I have this scratched up in here is because, again, I have marked the other side of the board trying to follow that. And I have put, believe me, hours into this computer. Let me just find this spot. I might have it just with the glasses. I might be able to see. Let me move you over to this side now. And I have put some markers so I know exactly where I am. So here is pin 32, pin 13, and this is pin 16. You see the same 3.7 ohms. And then in here is where that IC goes down for the alternator. You see we got 3.6. And I'm actually touching the one for the injector here. If I go over to the alternator pin, we can see 0.2. So this is definitely the IC. This is on the other side of this IC. So this is telling me that this is the IC for the alternator. And if I measure, again, from this side, if I measure from pin 13 to this same point in here, you see we got 0.00 or 0.2 ohms. So that's a perfect pad from here to here. So this is definitely the alternator chip that controls the alternator. And then from here, pin 62 on the other connector to injector driver, we got 0.18. So 180 milliohms of resistance. So that means that these are a direct pad and these are a direct pad. So something in between these two is shorted under the board. And I've been trying to find it because I want to help these customers. And this is what I'm here for, right? Try to, repair components. But this is where limitations about how much you can repair or not. The problem is it's in between the layers. And I'm not sure what else is there because if I break those in between and I make, a jumper to let's say, break that in there and jump it in there, which it would be a Frankenstein, and I don't do that kind of things. I don't know what is in between. So am I just masking a problem that is going to keep shorting out, and then in 2 weeks or in 2 days or in a year, the computer will fail again just because I did try to solve it temporarily. I don't do temporary repairs. I do good, long-lasting repairs only. Why? Because otherwise, I'm not helping you. I'm just taking your money. And that's not what we do here on Mike Salazar Diagnostics. So yeah, Brandon and David, I'm sorry, but in this case, I will have to say this computer is not repairable. And the problem with this computer, as far as I have checked all of my tools, I'm not even sure that I can program it here. If I get you a used one, I'm not sure if I can program it. So I'm going to have to talk to Brandon, see if they can order one and try to do the programming using 4 IDS or 4 FJRS, I think is the new one, because this is a 2020. Otherwise, you might going to have to go directly to the dealer of the motorhome because it might be what they call exclusive because it's a motorhome. So it might be specifically done by that, and Ford will not allow you to do a programming because it's not a Ford truck, it's a motorhome. You see what I mean? So I'm not sure about that because I've never done it on this such a new modules for this kind of stuff that is not a Ford directly, right? All right, guys, so I'm sorry, well, not sorry. I hope that you like the information. You can see how I do my tests, how I follow the circuit inside. I always take pictures of high definition, and I'm not sure if I show you that. Let me close this software here 1 second. This is to show you the 2 connectors on the computer. Again, this is the one that has 103 pins, and this one has 95 pins. Going forward, that is the computer. As soon as I open it up, we saw the injector drivers in here, and then the alternator IC, integrated circuit. That's what IC stands for. This is the other side of the board, and this is where I was looking for to, to check the path, see where that was going. And just another closer picture where I have put all my numbers and everything. You can see what I was doing and poking around and carefully, because I'm very careful of working with the electronics. I have seen computers that scratch so much and destroy boards. Trying to find a component. I don't do that. I have a special tool that I can just sweep across. It's soft and then leaves absolutely no marks. But yep, this is as much as I can do. All right, guys. So thank you so much for visiting the channel. If you're here, please don't forget to subscribe to the channel. That really helped my small business a lot. And if you have any computers, automotive or marine instrument clusters, I'm going to put in the title of this video my website so you can copy and paste it from there. Now you see what I do, wire diagrams, try to find the pins, corroborate which pins are located in the board. They use continuity, resistance, and that's just the game, right? That's just the game goes. See you next time. Bye-bye.